Welcome, everyone, and I want to welcome to the monthly 3-Year Minds 3D talk show. This is a monthly event. It's every Friday of the last Friday of each month, and this month we're doing it a bit different. We're doing it in collaboration with Women in 3D Printing. Women in 3D Printing, we have our own virtual panel series that's once a month, and this month we decided to do it together. So with that said, let's get straight to the topic. Whether you're looking to adopt AM by bringing it in-house or through a service bureau, there are many obstacles to overcome, be it knowledge, design knowledge, quality concerns, difficulties with scaling production. Cost is obviously one of the biggest concerns. Not only is there the cost of the hardware, but also materials and software, among other things. And then there's the post-processing that's inevitably required. So how do we justify these costs? That's what we're here to talk about today. And to help do that, we have 3 fantastic panelists with diverse perspectives on the topic. So first, I'd like to introduce Naomi Murray. She is the Director of Advanced Operations at STRYKER. Welcome, Naomi. Next, we have Elena Laso. She is a business analyst at HP 3D Printing. Welcome, Elena. And last, we have Stefanie Brickwede. She is the Head of Additive Manufacturing for Deutsche Bahn and the Managing Director at Mobility Goes Additive. And welcome. So to get started, we're obviously today, the title of this talk is Justifying the Cost for AM. So I'd like to see if each one of you could briefly give us an introduction of yourself, what your experience, what you do within additive manufacturing, and give us, your thoughts on what does justifying the cost mean for you, or what does it not mean? Stefanie, do you want to go ahead and start? Oh, Stefanie, I think you're still muted. Stefanie was having some sound issues earlier. So let's move to Naomi, and we'll come back to you, Stefanie, okay?
Sure. Can you hear me?
Yes, we can hear
you. All right. Excellent. Hi, I'm Naomi Murray. I am a Director of Additive Technology or Advanced Operations for STRYKER. My team works on the development of additive technology to bring it, from that prototyping technology into a manufacturing technology. And from a cost perspective, and what does it mean to us and to me, I'm just going to go back to STRYKER's mission, right? We have a mission that's together with our customer. We're driven to make healthcare better. And so when we look at, does it make sense to use additive manufacturing or 3D printing for a product? It really is about what value is it going to bring to our customer. We look at, what are some added features. A lot of it is what are the unique properties or unique features that additive manufacturing can bring, and it's justified when it does bring an inherent value to our customer, being able to really, solve a problem clinically or help go together with another technology that really can do something positive in the healthcare industry for our customers.
That's great. Thanks, Naomi. Elena, do you want to go ahead? I believe you're still muted as well.
Okay.
There you go.
No, I'm not muted. Okay. So my name is Elena Laso, and I work for HP, and I have been for the 5 past years working together with customers to make reality the industrialized applications of multi-jet fusion. I'm very focused on the cost, so I am usually the one that intervenes to do business cases together with the customers. And also throughout these years, I have been doing these business cases for my own company, so for HP, and from that I get a lot of experience on that. So what happens is that about justifying the additive manufacturing cost is that we cannot justify it on any application, any use case. Companies must have some idea of where they should apply it, or at least we can help them find it. But you cannot say that 3D printing is going to meet all the requirements, especially with in some cases in which you're just thinking of substituting one manufacturing technology by another. 3D printing is not that. What really brings value is when you can shape your business model or shape what you're offering your customer with 3D printing. I mean, if it's availability, or if it's customizing, or there's another value that can really help you to justify the cost. Or at least when you have a wider view and you think, okay, I'm not just substituting the technology, I'm enabling rapid design, I'm enabling new designs, I'm validating a new technology that can later help me when the product is at the end of life and I need spare parts. So that wide view, and that's the way that we go to justify the business cases with our customers.
Great. Stefanie, how are you doing? Do you have your sound back? Oh, no, shoot, we still don't have it. Why don't you sign out and log back in, and we'll continue on in the meantime. Okay, so Naomi and Elena, you got to pick up a third of the panel. So let's get started. I think there are some topics actually that are more suited for you two anyways, and so we can kind of go along those lines to begin with. When we talk about justifying the costs, often it'll be based on redesigning things, specific features, specific applications. What, from your experience and from what you see in the market and what you see internally, what kind of applications and what kind of even features of certain applications really justify the cost of additive manufacturing?
I could go ahead and okay, start, great. I guess. I think it's pretty out there, well out there, that one of the ways that we use additive manufacturing within STRYKER is on our titanium technology, right? So that's a porous, three-dimensionally porous titanium called Tritanium, and it was really designed and developed to interface with bone and to allow for bone to interdigitate into the open porosity within that structure. And additive manufacturing really opens up the design window that we can apply the titanium structure and we can use to make that titanium structure. So we within our additive, we can really control every single strut in that porous structure. We can decide where to put it, and we can put it in places that we couldn't put porous metal in a different way of applying it, such as sintering it onto components. So we've found that really we've been able to affect stiffness of an implant or take away stiffness of an implant depending on the need by adding solid features within porous structures, taking away solid features within other spots in the porous structures, affecting the strength of the component so that it meets its function. And when we can do that, that's really when we can show value of additive manufacturing into our products, because we really can create things that we really couldn't create without any other technology, or with any other technology.
Yeah, I think that it's really interesting. I'm hoping we can get Stefanie back, because between you and Stefanie, we have both ends of the spectrum for additive manufacturing. I think for what you experience within STRYKER, it's producing things that you couldn't be able to produce any other way. Whereas Stefanie at Deutsche Bahn, they're focusing primarily on obsolete parts and spare parts at the end of the product life cycle, and things that they specifically don't want to redesign. And so hopefully we can come back in, because there's both, it's interesting to come from both directions, I think.
Yeah, absolutely.
Elena, how about you?
Yeah, so what we are seeing as the application that have the greatest fit and where the most value comes from is also those in which our technology can do something that other technologies can't do. And it's very similar to, for the porous example that Naomi just explained. We have just released our molded fiber business, because now we are able to do molds in which we can put pores at certain positions that we can make, the packaging made from paper pulp. And that brings not only the value that we can do that faster than the current technology that will be heavily manual, but we are also opening the space of sustainability by substituting the current plastic thermoform packagings that are being used today. For example, for those consumer electronic devices, when you get a consumer electronics device and you have this packaging that is usually done by thermoforming. No? So that's an application that where 3D printing is bringing an additional value. So both on how quick can you do it and what's the performance of it, and also the sustainability vector. Other applications similar to that would be anything related to orthotics that we can do something. I mean, I'm talking mostly about plastic. That is the field that I know about, but we can do some orthotics, and also one of our businesses also dental orthotics. Or also when we are working with lattice structures and elastomers, I don't know if you or someone from the SN already has seen a post in LinkedIn that we are able to make customized midsoles for athletic shoes. So in this case, what we are able to do by design, by doing this lattice design specifically to the material that we are developing, is that we can control the energy rebound that we have at certain areas of the shoe, and thus do a customized shoe for the runner in this case. And that's another example of high value application, I would say.
So we've got customization, speed, sustainability. What else is missing here? I mean, Stefanie, right now we're talking about applications that drive value for AM. If you're back, we got sound. I think you have an interesting one to add as well.
I hope so. Can you hear me now?
Yes, we can hear you.
Oh,
excellent.
Thank goodness. So, yeah, we have a totally different use case. So, as you just explained, I'm responsible for additive manufacturing within one of the biggest railway companies in Europe. And what we do is at the end of the life cycle of a train, of the infrastructure, we start reprinting, re-engineering spare parts we urgently need and we can't get the markets anymore. So what we do is something I always call clones. And those one-to-one copies are absolutely different to prototypes or newly designed products where you can design for additive. So usually we just copy things. And all the experts in additive manufacturing would say you don't use the whole potential of additive manufacturing. But indeed, for us, it's a huge use case. So to give you just a short idea, we have high-speed trains running for more than 30, 40 years. After 15 years, we can't get the spare parts on the markets anymore because the suppliers are out then, and so we put everything on stock. Our warehouses are full, but sometimes, yeah, it's always to make an educated guess how many parts you would need. You can't really know this definitely. So sometimes we need parts and then we reprint them from different materials, different technologies, and meanwhile even huge steel parts linked to the braking system, highly safety relevant, and we are very successful with that.
Great. I think this panel is such a great mix of people because, like I said before, we've got the whole product life cycle here. And I think you have a really interesting point in that you don't have to cover the whole life cycle for there to bring value to AM. You know, people know 3D printing for prototyping. You know, a STRYKER is one of the best examples of using it in production. And now here you have an example of where it really is valuable, even just for replicating parts for obsolescence. It's a great example of the whole life cycle there. So we kind of touched on it a little bit here on the applications, but is there anything we haven't touched on in terms of how you would define value as it pertains to additive manufacturing outside of cost? You know, we've talked about speed and the obsolete parts. I think, you know, post-processing, there's some issues there to address. And what are some other factors that we should be considering when we're looking to validate the cost?
So, I mean, I think, Elena, you brought up the personalization or in the medical industry, the patient-specific. And I guess I don't know if this goes away from your comment on cost, because cost still is a factor in those items. But I would say that in some cases, your personalization or your customization is maybe deemed more important by your customer. We do have a 3D printed faceplate as part of our cranial maxillofacial business, and within the head space in particular, having that patient specific, the matching of your features, is an important part of value to our customers. That is, sure, cost is still a consideration there, but it brings value beyond just what does a component cost to your customer as well.
And relating to what Naomi said, I mean, there's another medical application. I was working earlier this year with more focus on medical applications, that is anatomical models. And that's, I mean, it's quite difficult to make the business case in Europe because of how the public system works. I mean, it's very difficult to find the data, but with the United States and how the health system works there, I mean, it's pretty easy to do it. And besides that, I mean, what you're bringing better chance for all the patients that go under surgery. So statistics say that if you have an anatomical model, the chances that your surgeon will change the approach of the surgery is 40%. That is crazy high, I would say. And that means that knowing, so what 3D printing brings here is another level of value. Again, I want to bring the speed. So we've been all through this pandemic, and HP, and especially the site in Barcelona, we collaborated with our partners to bring supplies to the hospitals because we were in lack of supplies for valves, for respirators, for masks, for protection. So that's quite intangible. But I also want to touch here, like when you get out of supplies, when the system really breaks, 3D printing brings this value, and this is not quantifiable, but definitely is important. And governments, I think that after this crisis, have been thinking on how to enable flexible capacity for manufacturing medical supplies in the future, and it's a good point.
By the way, not only in medical. So I'm also representing a network which is called Mobility and Medical Goes Additive. So I see always both sides, like the medical aspect and also the mobility aspect. And within the mobility aspect, we had huge problems caused by Corona, because from one day to the other, the supply chain stopped. So we couldn't get any spare parts from Spain, from Italy, from Turkey anymore. And that really helped us to convince also many more people within different levels of management to invest into machines, because they know exactly as soon as another crisis, pandemic, whatever you can think of, might occur, then we now have a solution, which is additive manufacturing. And at least for an interim time, so just bridging the gap until those supply chains work again, you can use additive manufacturing and you're capable of producing.
Yeah, I think the silver lining that's come out of all of this, the crisis in the last 9 months, essentially, is it's given a lot of visibility to how much additive can reduce the risk in the supply chain across the board in all industries. So we've talked through, where it makes sense. How about cases where it doesn't make sense? What are the business cases where we shouldn't be looking to additive? Because I think, again, it's not the cure-all. It's not going to be something. It's not going to replace injection molding. It's not going to replace traditional manufacturing. What are the cases where it doesn't make sense?
Well, I can talk about my failed experiences. No, but within my company, there's a lot of lines of products, and some of them are produced millions per month, and some of them are produced on the hundreds or thousands per year. So I can already say that if you're looking at a high volume, and high volume is not only millions, so for us it's something that goes on a few thousands, then it's quite complex to justify the case for 3D printing. It's unless you look at the whole product life cycle, looking at how early can you design, how many changes can you do it, and you look at the end of life. But what happens again is that if you are comparing, and in our case it's plastic, it's a plastic technology, so we are comparing ourselves with injection molding, which is very cheap. So if you have capacity to have inventory, if you have high volumes, if you're producing in Asia, if you don't have an issue of having to wait for the spare part because you have a lot of distribution centers in the middle, this is not, if you're not going to change how you work or your business model, 3D printing is not for you in this case of millions. And then I have another interesting case that I wanted to bring here, especially because Stefanie is also here, because I was working really, last year I was in a project working with different companies of the area, looking at how could we improve their spare parts model and justify the investment, but only looking at the spare parts and sustainability vector. And that was quite an interesting project. But sometimes what has happened, I mean, in one of the companies, it was really curious. We went through all the inventory management system, and in the end, what really came out is that they needed a financial controller, because they had a company with all the services, all the parts that they really needed, and it was not even a critical part because they were in the business of making swimming pools. Okay, so it's not a life of death business, no? That you have to wait another week until the part is made by injection molding, or maybe 1 month. I mean, it is not that critical. So it really didn't make sense, and it was exploring that I wanted the spare parts cost model, the spare parts business case to make sense for any company and so on. And so we went through every company, following everything. It does not make sense for every company. If you're not going to change anything upwards on the design, and if you are not going to use it for a better service level for your customer because you don't need it, then it's not for you. No, sorry, Stefanie, maybe I stepped a little bit.
So I think it's always interesting to learn about all those different use cases. And the big problem we have is if you want to decide whether you print a part in an existing train, infrastructure, mobility mode, whatever you can think of, you usually would need the total costs for the whole life cycle. And hardly any company has those costs. So this is a theoretical thing we all would love to have, but hardly anyone, even not the automotive guys, do have the whole transparency about the costs. Yeah, and that is also one of the problems. If you want to compare costs, additive manufacturing, former technologies, of course, you always have to take into account also other parts or other modes of costs too over a life cycle. And that is definitely also one of the problems, the lacking transparency.
Yeah, it's very difficult to find all the data when you go to help them. So where is your original 2D drawing for the part, and how are you storing this, and what is your strategy if the car is going to last 20 more years? I mean, they don't have it clear at all, and you have the system with tiers. I mean, we also went into automotive. It's complicated.
Yeah, and I was just going to weigh in. It's probably similar to for us for what you said, Elena, about it might depend on the number of parts you're going to make and the features that you have on the parts, right? So if they're very complicated and can't be made with injection molding or casting or forging, you know, additive is a great solution. And then lo and behold, it's also a cost-effective solution because you can't make the part in any other way. And that has been some of the most successful ways that we've used it, is that, you know, the features you can have using additive manufacturing provides that value, so it makes sense. I do think there is a bit of a break point too. Like there's a industry that doesn't make millions of parts at one time, and you might find that even though additive is more expensive when you're making millions of parts, it can be cost effective when you're making fewer parts, especially if your investment into, you know, capital equipment is less than maybe if you were going after higher, like an injection molding or a casting. I haven't really necessarily worked with some of those models, but I could see that being a nice filler where it might be a spot that additive manufacturing could be used. And then if I go back even, Stefanie, when you're talking, it's very much to me again about that customer use case and what you're trying to do for your customer. So I can't imagine your customers would really want, you know, brand new trains being made all the time. It would add to the cost of the infrastructure, it would add to taxes, it would add to the cost of the tickets. And so in this case, if you can't get the parts in any other way, additive has to make sense, or any way you can get them seems to me just intuitively to probably make sense. So, you know, who's your customer? What value are you trying to bring across the board in the whole supply chain? You know, and then you have to decide, looking at how additive can be used, can that bring value to your business and to your customer?
That's great. So we'll switch over to, there's some questions in the chat that I want to get to while we're going on this topic. One question from Swapnil: how do you compare the cost of using additive manufacturing and traditional manufacturing processes? Since there are many advantages, what metric do you use to judge if additive is the best way to go?
So in general, I mean, it's very difficult to compare it throughout the whole product life cycle. So usually the business case that you do is only for the manufacturing phase, but that gets you that in that case you are missing out information, like if this is bringing you an advance in how to design, if you're going to do less reworks to the mold, if you're going to be able to use this technology in the future. So it's so you begin there, but then it's complicated to do it in general. Usually what happens, or what should happen for the best fit of 3D printing applications, is that 3D printing enables a new business model, something extra for your customer. And then you're using the assumptions that you're going to have extra revenue somehow, or that you're going to have a new business model that opens certain market, and then the business model change a little bit. I mean, it may not make sense just to change just the manufacturing technology. I mean, looking only on that breadth doesn't add up. I mean, doesn't give you the whole information. I mean, I'm not saying that it is not there, no, because for some technologies, for us, when we move CNC parts or metal CNC parts to plastic 3D printed, it usually makes sense for complex parts. So in that case, it usually makes sense for certain volumes and certain parts. I mean, I don't know if I am.
I mean, if you have individualized parts, it's always quite easy because additive manufacturing is a perfect technology for that. But if you have parts, if you want to reproduce them, then the minimal amount of parts you would have to buy from suppliers, that's definitely one of those figures we are looking for. So also you already talked about molds. If you want to produce small amounts of parts, then the cost aspect for molds is very high usually. And then it definitely makes sense to print the part. But what also can be done is to print molds for metal parts. Yeah. So this is also a great step, because then for us, safety relevant parts play a huge role. And with the safety relevant parts, you have to prove form, fit, function is the same to get the approval, the certification for those parts. And if you can stick to the former technology, just by printing molds, for instance, then it's you're faster, you're cheaper, and you can stick to the former certification process, which for maintainers makes it much easier to use additive manufacturing.
Mm. And if I weigh in on our titanium products, right? We're adding a feature. We're having new products. You know, there's a business model around your new product that includes what is your return on your investment. So certainly, it's got to make sense. You know, what you think you're going to be able to sell a component for, how much it's going to cost to manufacture. You know, how much of a new market is it going to gain you? That all goes into when end use components. If looking at is it worth it to use additive manufacturing compared to other technologies to create the parts. But again, if you go back to that we're adding features that we can't do, you know, in our titanium, for example, you know, that is it's a helpful case to be able to add something that is going to add value to the customer. Really helps the case in our case anyway.
Mm-hmm. Mm-hmm. And sorry, because I didn't put it before, but we also have, like, if you are comparing two technologies, the analogical one and or 3D printing in this case, for example, injection and 3D printing for parts. So what another way to do it is when you consolidate parts. This can only be done. This can also be done in injection molding, but in 3D printing you can bring mobile parts. I mean, this is just and add features, threads, so everything comes out. I mean, you probably are not able to see the complexity of the part inside, but you can bring a lot of features together. And while this part is perfectly manufactured with traditional technologies, but in several parts, that brings an additional cost reduction to your business case that may justify the change to 3D printing.
So Naomi touched on the ROI, and I think this is especially specific or pertinent to you, Elena, with the HP, with the printers themselves. I mean, when a customer comes to you and says, you know, how can I be sure of the ROI? What are the factors that people need to keep in mind when calculating the ROI for their specific application, and what is your how do you help address that?
Yeah, so I mean, it's impossible to do a generic business case. What we do is that we part from real assumptions that we have from real facts, either that because we have experienced those in our manufacturing capabilities or because we have had those experiences with customers. So we have a very detailed counting of our consumables that we use already. We have a lot of inputs from different customers on how do you use our systems, if there is idle times in the middle. I mean, in the end, we have to build a whole factory budgeting model to understand. So the costs are quite important before doing the ROI, no? And for that, we use all this data. We work with the customer. So how are you going to work? Are you going to do one shift and a half? Are you going to work 6 days a week? How do you think it's going to be your workforce? What is your rates for a skill? What are your rates for non-skilled? I mean, how are you going to work? And then we build a model together with our customer. I mean, we have our own inputs, but in the end, is their ownership. They know how much are they paying for the rental floor, or how much are they paying for the power. So it's a hand-in-hand process. We can. I mean, I know there's trials to do a model that you can probably insert the part and it will tell you how much does it cost in injection molding and how much does it cost in a 3D printed technology. But that is very difficult to do because in the end, every manufacturer has a different way of doing things and different costs. So it's very difficult to do a quotation for a part if you don't own the factory. So that's why we have to work together with the customer. So he believes that the business case that we're doing for them is specific for them with all the inputs. And then they're in the end responsible for giving out what is going to be the business models and how are they going to use it. I mean, I'm not doing the market research to know that these parts are going to have certain demand or not. They are the ones that have to say which is the demand that they're going to have, and they are the owners of saying how much is the average revenue per unit that they're going to have. I mean, this is not, but this is the way that we work with customers, and it's a process, and with customers and partners. So I probably have like 3 side meetings with the materials company, the manufacturer company, and HP working together. So what is your assumptions here? What have you put there? Those are most of my days, actually.
Mine too. So if you're in a huge corporate, you have exactly the same problem, because there you have to pick all the information. And what I find really interesting is, as soon as you have someone in the organization who is really capable of dealing with additive manufacturing and who really understands what it means, it's much easier. So I guess we also have one question about this. Do we think that people are trained enough? No, they are not. But as soon as we have some of those diamonds, I'm working for a huge corporate, so 300,000 employees. And of course, there are many who already have their private 3D printer. And as soon as they know what the logic is and how to deal with it, they are very helpful. And so this is something we have to enlarge, the number of people who are really capable of thinking in AM. They don't have to necessarily be capable of designing, but to understand what the technology means, what is possible and what is not possible. That definitely helps.
Yeah, I think that base is growing, right? So it's compared to 10 years ago or 20 years ago, you know, there's more and more people familiar with your design freedoms that also have design constraints. But yeah, there is a question there in the chat, and definitely I think that we you know, more and more people who know about the technology will continue to push the technology and the various forms of 3D printing technology, because there are a lot of them, continue to push them to be better and better, and we'll find more and more use cases. But yeah, it always helps to have more people know about it, know how to design for.
So that kind of touches on one of the other questions on here from Greg Waters, is to what extent do you think that COVID has helped remove the hype, and I assume he means hype in the negative way, around 3D printing, and create something a bit more realistic? I think on it a little bit with supply chain. Is there anything else that maybe would be that has come from COVID?
I mean, I think there's a lot out there. You know, you troll through LinkedIn, you know, over the past 6 months, and especially in the early on, there were a lot of even individuals who were able to respond quickly, right, to needs of hospital workers, healthcare providers. And so it even though it was already kind of a word you could find in the home, I think it became more of a common word, and probably piqued a lot of interest as well, just from people in general, which builds then on that AM knowledge. Because if you think of, you know, people now have more interest in it, they're going to look more into it, maybe look and see, oh, it was helpful here, where can it be helpful in my daily life when things calm down a little bit.
Mm-hmm. Mm-hmm. In general, I'm not that negative about hypes. I think the hypes we have are very, very helpful to convince the management and the CE level. So I would not talk that negative about hypes. But if it comes to the point, what have we learned from COVID? There are many, many points. So within the network, when COVID started here in Europe in March, we tried to help certain institutions and hospitals also in Spain, because Spain was already on the peak of the wave, and Germany still wasn't. So we tried to help with the additive manufacturing network. First, many people try to design certain things like very innovative mouth-nose shields with just a paper in, but also those face shields, you all know that. But what we've all learned, everybody wanted to help and wanted to save people's lives, and said, why is certification so relevant at the moment? We just want to save lives. And then they definitely learned, although they mean to do much good, they also have to bear in mind that there are certain certifications and there are certain quality levels they have to meet. And that was a huge discussion between the willingness to help from the AM industry, and on the opposite, the hospitals and also the medical device producers, like in Germany, it was Moderator for the breathing machines, and not STRYKER. But to discuss those things, and still you have to meet those certification levels. So the whole AM industry learned a lot via COVID about the need and the necessity for certification and qualification in the whole printing process. And we know that there were examples in China. They produced parts for breathing machines with a powder bed technology, and they were not able to 100% eliminate all the powder particles. But then those COVID patients who already had huge problems with breathing, they breathed in those powder particles. And this is exactly the point where you learn that you have to meet such standards. And that was a great effect of COVID too.
In our experience, so here in Barcelona, we also did a COVID task force, and we were producing parts, and we were producing actually some parts for ventilators and adjusters, and we were successful going through the certifications. I mean, it was a pain. We had to go throughout the whole process. We tried to accelerate it as much as possible, and also it's called Agencia del Medicamento here, was also willing to help to provide the parts for the hospitals. We went throughout the whole process, and we learned that we were able to do parts for the medical segment. I mean, we are already working with STRYKER in some applications, and we have done other medical applications in the past, but there were certain certifications that we thought that we were never going to pass. With focus, we learned that we can do it, and that additive manufacturing can meet the specs, and especially plastic parts from powder bed. We had a lot of uncertainty around us that we were going to be able to put the parts in respirators, that we were, how do you say, able to be neutral. No, how you say, when a part that has to go into an OR has to be
Sterile?
A sterilization process. That we were able to do a sterilization and so on, and we went through the whole process, and we learned very quickly. So it was a quick win for us. And something that our organization learned was that when we put focus on doing something, we are able to meet our targets. And that was, I mean, you always say that, and we are a young organization in HP. The 3D printing organization is quite young. It's only 5 years old. And we've been looking at different segments and where to go, and basically looking at everything. So when we had this COVID task force and we see what we could do, focusing on developing the application, focusing on getting the certification, focusing on delivering, on manufacturing big quantities, and doing this, we learned that we can do it. And we learned at organization level, because at individual levels, this we all know, no? But at organizational level, we learned this. So we hope that now, with the new organization that we have, we will be more focused on certain applications, and we will advance faster there. And that was a huge learning from the pandemic.
Great. Well, I want to wrap up with one question, but first, I'm going to put up at along the right-hand side details for the next 3D talk show the next month. You can see the details here. It's going to be a great one with GE Additive, Desktop Metal, and EOS. I believe Rick Fulop, I can't actually see it very well on the right-hand side, but I believe it's Rick Fulop actually is going to be from Desktop Metal, and Deborah Rogers from GE Additive, and Marie Langer from EOS. So if you can register for that now using that link over on the right-hand side. But back to this topic at hand, to wrap things up today, I think, you know, the topic that we're talking about today is justifying the costs for additive manufacturing. And I think a lot of people are out there that really want to bring this in-house, and they really want to convince their leadership and their executive team that this is something that is right for their organization. What are your thoughts, each of you, in terms of what kind of advice would you give them? What would you tell them to do? How would you tell them to go about getting that, accomplishing that goal?
Yeah, I'll jump in. I'm going to go back to what I said at the beginning. For us, it's really what value is it going to bring to your customer, which then, you know, ultimately brings value to the organization. So if you can really tie what it is we're trying to do with 3D printing to what it's going to bring your customer is going to want it. That's good for your business. That's good for your company. It helps make the business case. So it's really understanding your customer and what you can do with 3D printing to make that relationship stronger. At least that's in our customer-centric organization, that has what has worked for us in the past.
I would say that 3D printing is not magic. I mean, again, you have to look you have to choose where to apply it. You have to choose what is going to be your business strategy around it. What really doesn't hurt is that the company does go out and explores the technologies available and trains the workforce. And as Stefanie mentioned before, the more people that knows what to do with the technology, when the next business opportunity comes into your company, you will look at the options of 3D printing. So it doesn't hurt to train your people and to make them aware of what you can do with different technologies again. And this is only the beginning. So eventually in the future, there will be much more technologies, much more materials available. The technologies will be much more reliable for manufacturing, more detailed, better dimensional. So you have to start learning today.
Yeah, definitely. So we are in the network often asked that question, what can you do if you want to start with additive manufacturing? What we did is within the network consisting of 120 companies, we brought together our experiences in a book, which you can even buy via Amazon. It does not cost very much. And all those experiences are here in a summary, and you have to train people. You have to convince your management level. Otherwise, it's hard to bring it in. And then you have to look for the first use cases, of course. And what we did within Rail is we did some use cases, although they were not from an economic level, they didn't really make sense. But to show what it's possible and to get some more experience concerning the new technology, it really helped. And the whole thing is a change management process. It's not a technology thing, it's a change management process thing.
Is there any specific bits of knowledge or, or that you think is more important than others in terms of, is it design knowledge? Is it application knowledge? What do you think drives most of these decisions?
The thing that comes with design is that actually, so what we are learning with our technologies and with the technologies that are growing around is that things that are not possible today might be possible tomorrow, and in our own technology is evolving. So even when you learn everything about design, I mean, you have to be open to just the concept of additive manufacturing and maybe go and push the companies like us doing additive manufacturing technologies to bring us a problem, and we will look into it. So bring us your problems. I mean, we have discussions of this type with several customers, bringing us their problems, and this is, and we've been helping them having more success in some cases than others. But this is not telling you that you have to have all this knowledge. I mean, explore, but then bring us the problem.
I think, you know, it seems unsatisfying to say and hear probably, but I agree. I think it's that knowing what your problem is. What problem are you trying to solve? And it's, you know, for us, it's what is our customer problem and how to maybe translate into how a technology can help that or how additive can help that. But I think we are successful so far to date. You know, we're successful. I plan to be successful in the future with additive, you know, because we had a problem to solve and we knew what we were going after and we were able to make it work.
I think that's such a good point. I think it's a really simple, but very powerful is if you don't have a problem to solve, then you're already dead in the water. Great. Well, any closing thoughts? Or we?
Maybe I would like to encourage. There are problems, and maybe you just don't know about them. And, keep looking for them. Keep encouraging those people, and you will find the problems, and then you will find the solutions with AM.
That's great.
That's a good point. Yeah.
Great. Well, thank you, ladies. We will be doing also Women in 3D Printing will be doing another panel in early December. Details have yet to be announced, but it will be on the future of polymer 3D printing. And keep your eyes peeled for those details coming out in a few weeks. But thanks, ladies. And
thank you.
Great. Good to have you guys.
That's my pleasure.
Great. Thanks, everyone, for attending. Bye.
Thank you.